Oh man, you guys, I know you're pumped up for example 2. Let's go. All right, so example 2, we have a parallelogram. Look at that beautiful, beautiful parallelogram. It's lovely. And we have these diagonals going through the parallelogram, okay, which I'm going to zoom in a little bit so you can see it a little better. Okay, so we have each piece of the diagonals labeled. We have FJ is 4z minus 9, GH is 2z, EJ is 3W, and JG is W plus 8. So we are looking for the variables and the sides or angles containing the variables. Okay, so not only are we solving for W and Z, we also need to find the lengths of all these pieces of the diagonal. Okay, so do you remember any parallelogram properties that have something to do with diagonals? Because I see a bunch of diagonals in my picture. Holy hot dog, you guys nailed it. Okay, so diagonals in a parallelogram bisect each other, which means they slice each other in half. Bam, bam, they're vicious creatures. They slice each other. Okay, so that means that these two are congruent, which I'm going to mark that in my nifty picture. So these two are congruent right here. The Z ones are congruent. So GH is congruent to FJ, and that also means the pieces of the diagonal containing W are also congruent. So 3W is congruent to W plus 8. Okay, so if they're congruent, how are we going to set this up? You guys are so smart. You do set them equal to each other if they're congruent. So basically, we're going to set the W pieces equal to each other and the Z pieces equal to each other. And then we'll find the W and Z, and then we can find the pieces of the diagonal, what their lengths are. So let's get going. I'm excited. So these are all congruent. Okay, so let's start with our W's. Might as well, right? So we have 3W equals W plus 8. Alright, let's get W on one side by itself and solve. So first, we need to combine the W's together because they're besties and they want to be together so badly. Okay, so I'm going to bring my W to the other side, which there's secretly a 1 out in front of that W. Okay, which the way I bring a positive W to the other side is by subtracting that thing on both sides. Bam. So 3W minus W is 2W, and these cancel each other out. So we have 2W equals 8. Now how do I bring the 2 to the other side? You guys are so smart. You do divide it because it secretly is multiplying to the W. So divide 2 on both sides. 2 divided by 2 cancels and turns to 1. 8 divided by 2 is 4. So my W is 4. Yay, we found W. But now I need to find what these nifty pieces of the diagonal, what their lengths are. So we're going to start with the 3W piece, and then we will move on to the W plus 8 piece. Alright, so since we know that W is 4, that means I can substitute in 4 wherever I spot a W, and I can solve for the measure of the diagonal, which, if I do it correctly, we know that these two should be congruent, so we should get the same thing each time. So let's see what happens. So 3 times W, which I'm going to replace with a 4. And 3 times 4 is 12. Okay, so one of my lengths is 12, which means this one better be 12 or you need to reevaluate your problem. Okay, so W, which is 4, I'm going to replace that with a 4, plus 8. And 4 plus 8 gives me 12. Holy hot dog, we got the same thing. Yay! Awesome, you guys. Now we're pretty much going to do the same thing with the Z. So if you think you understood the W, I highly encourage that you try the Z on your own. Okay, but you can watch me if you want to. Might as well, right? Alright, so the Z's we know are also congruent, which means, like with the W's, we're going to set those bad boys equal to each other. So I'm going to say 4Z minus 9 equals the 2Z. Alright, so let's start solving this thing for Z. We'll separate it. Alright, so I need to bring my Z's together first, okay, which I'm going to bring the 4Z to the other side. They're besties. They want to be together. So the way I bring 4Z to the other side is by subtracting it. So I'm going to subtract that thing on both sides, which 4Z minus 4Z cancels out and turns to 0. 2Z minus 4Z is negative 2Z. So I'm currently left with negative 9 equals a negative 2Z. Alright, and I gotta get z by itself, so guess what, you guys? I better bring that 2 to the other side, which the 2 is secretly multiplying to the z, so the way I bring that bad boy to the other side is by dividing both sides by -2. You guys knew it. Okay, which -2 divided by -2 cancels and turns to 1, and -9 divided by -2, first of all, a negative divided by a negative is positive, and I can't reduce 9 over 2 down anymore, so z is just simply positive 9/2. Nifty, right? And fractions are our friends, so this is going to be awesome. So I know what z is. We got the first part done. Yeah, you guys rock. Okay, now I need to find what each piece of the diagonal is. So I need to substitute in my z, and then I can solve. So we need to do this for the 4z minus 9, as well as the 2z. Okay, so everywhere I spot a z, I'm going to substitute in a 9/2. And fractions are our friends, you guys. We love fractions, so you're going to love substituting this value in for z. Okay, so we have 4, and then I spot a z, so I'm going to put a 9/2 in, so times 9/2 minus 9. Alright, which when we multiply fractions, we go straight across, which is the secretly over a 1. So we're going to go straight across. So 4 times 9 is 36, over 1 times 2, which is 2, minus 9. And 36 divided by 2 is 18. And 18 minus 9 is 9. So one of my pieces of the diagonal is 9. And remember, you guys, if we did this correctly, these two should be congruent. So I better get 9 for the second one. So let's see what happens. So 2 times z, which z is 9/2. So 2 times 9 over 2, which there secretly is a 1 under the 2. Alright, and to solve, we're just going to go straight on across. So 2 times 9 is 18, and 1 times 2 is 2. And guess what, you guys? 18 divided by 2, holy hot dog, is a 9. We did it correctly. Look at that awesome problem. Didn't you guys have so much fun doing that? I had a blast. I hope you guys did too. That was so exciting. Holy hot dog, right? Oh, nice job.